Hello, good evening students. Let us try to understand the bond parameters. Bond parameters are like that: bond length, bond distance, bond angle, bond energy. These are the terms which are known as the bond parameters, as they are describing about the bonds. First of all, let us look over the bond length, student. The average distance between the nucleus of two atoms is known as the bond length, represented in angstrom. Okay, so what do you mean by that, student? That is, they are saying the average distance between the nucleus of two atoms is known as bond length, represented by angstrom. So Cc single bond length is what is there, 154 angstrom. Now, what are the factors which are responsible for the bond length, student? The first factor is bond order. So bond length is inversely proportional to bond order, student. It means if the bond order is more, student, suppose 3 bond orders there, so bond length will be smaller, student. Okay, if suppose bond order is 2, so again the bond length will be little more, and bond order is 1, so bond length will be very high. It means, that is, if you talk about, that is the bond length, student, so that is triple bond, okay, then double bond, and then single bond is there. So highest bond length this, then this triple bond. So order of bond length, this is the order of bond length, student, right? Now let us see, student, bond length is inversely proportional to bond energy. It means if the bond length is more, the energy is less. Okay, bond energy is proportional to number of bond. Suppose bond energy, you see, single bond 80 kilojoule per mole, double bond 140 kilojoule per mole, triple bond 180 to 200 kilojoule per mole. It means that, student, if your bond length, bond order is increasing, so bond energy is also increasing, and bond length is decreasing. You can see here the bond length of triple bond is what, 120, 1.20, double bond 1.34, and single bond 1.54 angstrom. Resonance. Okay, so resonance, what is that? Is the, if you see here in the benzene, that is the single bond, double bond is 134, double bond is 154, but in actual it is found is a 139 angstrom, student. It means this double bond is in the benzene ring is continuously rotating. That is what the resonance structure. See in the benzene, student, what you are finding, this is, and if you see, that is in the next structure, very next structure, you will find this. So if you are equating this, student, so what will come, this will be the, this bond is rotating, so that is what is known as what, resonance structure, resonance hybrid structure. Resonance means what, student? If you are defining resonance, that is, if the two structure, that is structure 1 and 2, is not capable to describe all the properties of molecule, then intermediate of this structure, that is resonance hybrid structure, HYBRID, hybrid structure, can describe all the properties which is known as resonance structures. Okay, student. Now let us see bond angle. It is defined as the angle between the orbital containing bonding electron around central atom in a molecule. It is defined as the angle between the orbitals containing bonding electron pairs around the atoms in a molecule. Now, bond angle is expressed in the degree which can be experimentally determined by spectroscopic method. Right, student? See, next one, if you talk about this one, what they are saying, the bond angle is expressed in the degree which can be expressed experimentally or experimentally determined by spectroscopic method. And what is the bond length, student? They are saying it is defined as the angle between orbital containing bonding electron pair around the central atom. Now see, student, the angle between any two adjacent bond is known as bond angle. Now, what are the factors which is affecting the bond angle? Number of bond, hybridization, and S character. So let us see, student, the number of bond. If you see bond angle, student, it is proportional to number of bond or bond order. Okay, so student, more the proportional, more the bond, more the number of bond, more will be the bond angle. Okay, means bond angle is number of bond. So here the C triple bond is there, student. So bond angle is 180 degree. double bond 120, single bond 109. So bond order increasing, so it means bond order increasing, it means bond angle also getting increased. Now next one is hybridization. Hybridization. When hybridization is same, bonded atoms are same. When hybridization is same, bonded atoms are same. That is, central atom and lone pair are different. Okay. So bond angle is inversely proportional to number of lone pair electrons. Okay. For example, you see student, that is CH4 no lone pair, so 109 degree. NH3 one lone pair 107 degree. H2O 2 lone pairs, so 105 degree. So it means if the lone pair is increasing, so bond angle is decreasing. Now that is when hybridization is same, the bonded atoms are same. So lone pair is same, but the central atom is different. This case bond angle is proportional to electronegativity of central atom. See, NH3, PH3, ASH3. So what is happening, student, if you are moving down the group, so bond angle is getting decreased. Bond angle is getting decreased. Why it is getting decreased, student? The rule is saying electronegativity decreasing. So bond angle is also getting decreased. So down the group, bond angle is decreasing, student. When hybridization is same, lone pair are same, central atom is same, bonded atom are different, then what is happening? Bond angle is inversely proportional to electronegativity of bonded atom. So OF2, Cl2O, Br2O. So here you see student 103, 109 and 116. So here is the hybridization is same, but the central atom surrounding atom are different. So this was the answer. Next, S character, percentage S character. So bond angle proportional to S character. BeCl2, BCl3, CCl4, 180 degree, 120 degree, 109 degree, 28 minutes. So decreasing order of bond angle. Okay. Next one is the bond enthalpy, student. Bond enthalpy means bond formation enthalpy we are going. So energy released when only bond, energy released when any bond is formed is known as bond formation energy or bond energy. Energy released when any bond is formed is known as bond formation energy. What is bond dissociation energy? Energy required to dissociate any bond is known as bond dissociation energy. Bond energy in diatomic molecule, that is bond energy proportional to bond order. So NN triple bond, OO triple bond. So decreasing order of bond energy. So greater the more the number of bond, more is the bond dissociation energy. Lesser the number of bond, less is the bond dissociation energy. Bond dissociation energy of polyatomic molecule. Bond dissociation energy proportional to average of all the bond. So here you see that is this is the methane. So that is 102, 105, 108, 83 kilojoule. So if you are calculating average, so 198 upon 4, so that is 99.5 kilojoule per mole. Factor affecting the bond energy. Okay. So what are the factor? That is electronegativity, bond order, atomic size, bond polarity, resonance, hybridization and lone pair electrons. Electronegativity. Okay. So bond energy is proportional to electronegativity. Bond energy is proportional to electronegativity. HF, HCl, HBr, HI. Right. So that is what, more electronegative atom, more is the bond dissociation energy. Next, bond order. Okay. Bond energy is proportional to bond order. The greater the bond order, 3, so more bond dissociation energy. 2 less, 1 very less. So that is atomic size. Bond energy is inversely proportional to atomic size. Okay. So even you see, student, so smaller the size, more the bond dissociation energy. Okay. So this is the what about the bond dissociation energy. Bond polarity. Bond energy is proportional to bond polarity. More the polarity in the bond, more will be the bond dissociation energy. Resonance. Bond energy increases with the resonance. Hybridization. Bond energy is proportional to percentage S character. So SP 50%, SP to SP 33. So that is bond dissociation energy is decreasing. Lone pair electron, bond energy is proportional to lone pair electron. Okay, so see, more the lone pair electron, lesser the bond dissociation energy. So on moving left to right, you see the bond dissociation energy is decreasing because lone pair electron increasing. Dipole moment we will study in the next slide, student. Thank you so much for watching, friends. If you find this video helpful, please do like and subscribe the channel.